and welcome back. In the last video, we learned what a discontinuous loop is, and we also learned how to identify the cell of discontinuity. We saw that there are three ways the links can enter and leave that cell in order to create a situation that we can benefit from. We call these ways types 1, 2, and 3. Duh! Today we're going to focus strictly on type 1. As you may recall, the cell of discontinuity in a discontinuous loop type 1 is going to have two weak links connected to the same candidate in an otherwise perfect loop. We are going to prove that the candidate with two weak links attached to it will turn out to be false and can therefore be eliminated. We're going to look at several examples, and we will also go through the interesting logic of how and why this configuration works the way it does. And I'm also going to show you an alternative perspective for a DL type 1 that will always give you at least the same result, but most of the time will prove to be even more productive than by simply envisioning it in the traditional way. All right, quickly before we begin, here are a few reminders. I will sometimes abbreviate discontinuous loop as DL and the propagation rules as the prop rules. In order to use any of the three DL techniques, you must be able to see all possible candidates for every cell in the whole puzzle. There can only be one cell of discontinuity, i.e. one cell where the prop rules are broken or where you find a contradiction, and the loop must otherwise be perfect, alternating strong, weak, etc. Okay? All right, here in this diagram, let's take a look at this candidate 2 up here in row 1, column 2. We have a weak link going over to this 2 in row 1, and we have another weak link going down to this 2 in column 2. And as you can see, there's a strong link coming off of this 2 over to this 2, and there's a strong link coming off of this 2 down to this 2. So this looks like a good place to start trying to construct a DL type 1. All we have to do now is to connect these two 2's with a perfect alternating sequence and we'll have it. And if you look closely, we've got a strong link between these two 4's, okay? And we've got a strong link between these two 7's. And then we can connect that little mini chain to these 2's with a weak link here and a weak link over here. Okay, and then we can connect the 7 and the 4 here with a weak link. All right, so now let's redraw this thing with all the arrows going in the same direction. And there it is, a DL type 1 with two weak links connected to this first candidate 2 in an otherwise perfect loop. So let's examine the logic of what's going on here. There are only two possibilities for any particular candidate in any puzzle, right? It can either be true or false. That's all it can be. It can't be in between. Ha ha. It can only be absolutely true or absolutely false. These are the two cases or possibilities for each candidate in the whole puzzle. So let's say case 1 for this candidate 2 up here in row 1, column 2 is that it is false, okay? But since there is no strong link coming off of that 2 in the row, the column, the block, or within that cell, there is no way we can test this assumption. We only know that it is one of the possibilities for that candidate. It could be false. And for case 2, let's assume that it is true. So now let's follow the inferences of our chain, starting by assuming that this 2 is true and see what it tells us, okay? And instead of talking about links like we usually do, let's talk about the inferences here. Remember, the inference is the most important thing. A link is just an imagined or physical depiction of the inference. And also remember that a strong link can provide a weak inference. So if we start by assuming this first 2 is true, we must start with a weak inference. A weak inference says that by assuming one thing is true, then that would imply that something else is false. If A is true, then B is false. And that is the case for this first inference. If the first 2 is true, then this candidate over here in row 1, column 7 must be false, because all the other 2's in row 1 would be false if this first 2 over here were true, right? So now the next inference must start by assuming this candidate 2 over here in row 1, column 7 is false, because that was the conclusion of the preceding inference. Capiche? So if this 2 is false, then this one must be true, and if this is true, this 7 must be false, and if this 7 is false, this one must be true, and if this 7 is true, this 4 is false. If this 4 is false, this 4 must be true. If this 4 is true, this 2 must be false. And if this 2 is false, this one must be true, and if this 2 is true, then this 2 up here in row 1, column 2 must be false. So we started out by assuming the first candidate 2 was true, right? But now the chain of inferences is leading us to the conclusion that it is false. And of course, this is clearly a contradiction. It is essentially saying that if this 2 is true, then this same 2 must be false, which doesn't make any sense. And as we know, when a conditional statement leads to a contradiction, the premise must be false. And this means that our original premise of the first 2 being true must be wrong, and therefore it has to be false. Does everybody get that? So in case 1, it is just plain false, and in case 2, if we try to assume it is true, the chain tells us that because of the contradiction, our premise must be false, which leads us to the same conclusion. So either way, it is false and can therefore be eliminated. The tip-off is that there are 2 weak links connected to this first candidate 2, which breaks the propagation rules in an otherwise perfect loop and results in a contradiction. This cell, R1C2, is our cell of discontinuity. This is how a typical DL type 1 works. And please note that if you try to start the chain of inferences on any other candidate in the loop, it will break down at the cell of discontinuity and there will be nowhere to go. Like for instance, if we assume this 2 is false, then we know this 2 over here must be true, and if this is true, this must be false. And as we know, there are no strong links coming off of that 2, so that would break down. The only way this loop is going to work is if we start and end on this 2 here in row 1, column 2. And you should all know by now that we could draw this same loop with the inferences going in the opposite direction, i.e. starting on this same candidate 2 in row 1, column 2, but making our first link down to this 2 in row 5, column 2, like this. And then a strong link over to this 2, etc. And then the rest of the chain would look like this. The inferred true-false values for all the candidates in the loop are going to switch because we are moving in the opposite direction. But as you can see, the end result will be exactly the same because we will still have 2 weak links connected to that first candidate, which means it must be false and can be eliminated because of the same logical proof, but in reverse. But now I'm going to show you a little trick. Let's take a closer look at something else that's going on here that you may have already noticed. If we remove the 2 weak links attached to this first candidate 2, what do we have? It is an AIC type 1, beginning and ending with the same digit candidate. We have strong, weak, strong, weak, strong, weak, strong. So we know that at least one of those 2 endpoints must be true, right? Which further means we can eliminate any other candidate 2 that can see both of those endpoints. And voila, that means this same candidate 2 is false. How about that? This is the beauty of logic. This shows that you can use 2 completely different methods of analyzing this situation, but if the methods are both logical and valid, they will each lead you to the exact same conclusion. So I hope you are all confident now that because of this configuration, you should know with absolute certainty that this 2 is false, without a doubt. And when the endpoints of an AIC type 1 lie in different chutes like you see here, there are actually 2 cells that can see both of those endpoints. One of them is this cell up here in row 1, column 2, where we made our elimination, and the other one is over here in row 5, column 7. And as you can see, this cell already has a 6 placed in it. But if there were a candidate 2 in this cell, it would negate the strong link here in row 5, and it would also negate the strong link in column 7. So there cannot be a 2 in this cell, or this AIC would not exist. So in this case, you would only get one candidate elimination, whether you envision this as a discontinuous loop type 1 or an AIC type 1. It wouldn't make any difference. But if the strong links on both ends of the chain are either within a bi-value cell or on a diagonal within a block like this, then it is possible to get 2 candidate eliminations with an AIC type 1. Here are the 2 endpoints of this chain. One here and one here. And so we know we can eliminate this candidate 1 up here in row 1, column 5, because it can see both of the endpoints, right? But this other cell down here can also see both of the endpoints, and if there were a candidate 1 in this cell, it would have to be false, and it would not negate this strong link that's in block 8, and it would not negate this strong link in this bi-value cell in row 1, column 7. So this would be possible, and you would get 2 candidate eliminations from this chain if this cell were not already solved for 9 and there happened to be a candidate 1 in there. But to get 2 eliminations from a discontinuous loop type 1 in this diagram, it would require you to make 2 loops one at a time. First, with 2 weak links connected to this candidate 1, and then another one with 2 weak links connected to the candidate 1 that might be in this cell. Now please don't write and tell me that because there's a naked pair of 1 and 8 in block 9 that this red colored one cannot exist in that cell. I'm only trying to demonstrate that it would be possible to get 2 candidate eliminations from this configuration if there were a 1 in that cell, okay? So you see, you are better off by envisioning this chain as an AIC type 1 because then you would get both candidate eliminations with one operation instead of 2. Now I realize that this may seem trivial, but it becomes much more important when the 2 endpoints lie in the same chute. Let me show you what I mean. All right, here in this diagram, let's start on this candidate 3 up here in row 2, column 2, and we're going to go weak, strong, weak, strong, weak, strong, weak, strong, and finally weak. And since we have 2 weak links connected to this candidate 3, we know that is false and can be eliminated. This is our cell of discontinuity. But we could have just as easily made the chain using this 3 down here and going weak, weak, and now we know this candidate is false. Okay? But if you envision this as an AIC type 1, like this, with these 2 3s as our endpoints, then we know we can eliminate any other 3 that can see both of those endpoints, and in this case there are 4. There's one here, there's one here, and there's one here, and there's one here. So you could draw 4 discontinuous loops type 1 to get those 4 candidate eliminations, but with an AIC type 1, you get all 4 of them at the same time. All right, let's go to the next one. All right, this time our cell of discontinuity is here in row 1, column 2, and we've got 2 weak links connected to that circled 4, so we know that candidate 4 must be false. And if we look at this as an AIC type 1, these would be our 2 endpoints, this 4 and this 4 right here. So the other cell that can see both of those endpoints is this cell right here in row 6, column 5, and there's already a 9 in there. But if there were a 4 in that cell, it could be eliminated because the strong links on either end of this AIC are both within a cell. They are bi-value cells, and the strong links are within those cells. So the presence of a 4 in this cell is not going to disrupt or negate either one of those strong links. So if there were a 4 in this cell, you could eliminate it, but in this case there's not, and you can only get one candidate elimination. So it makes no difference whether you see this as an AIC type 1 or a discontinuous loop type 1. Now I looked and looked, but I could not find an example where the endpoints were in different chutes and there were 2 candidate eliminations, but just know that it is possible. But only if the strong links at the beginning and at the end of the chain are either both within bi-value cells like you see here, or both on a diagonal within a block, or one of each, as I demonstrated earlier in this video, okay? But just keep your eye out for that in case it ever comes up. All right, let's go to the next one. Now here's an interesting one. I found this puzzle online on a website called Paul's Pages, where he gives short tutorials on all the various patterns. And he used this puzzle to demonstrate a discontinuous loop type 1. But I had to laugh when I saw it, and here's why. He correctly makes the loop with 2 weak links connected to this circled candidate 1 up here in row 1 to prove that it is false. And this is fine, but you could also choose this candidate 1 over here and make another DL type 1 with 2 weak links connecting to that, proving that it is also false. Okay? But what's funny is that this is really just a skyscraper, with these 2 circled candidate 1s as our endpoints connected by the 2 1s down here in row 9. So we know that any candidate 1 that can see both of those endpoints is going to be false, so you could eliminate that candidate 1 and that candidate 1. So I just thought it was odd that he would choose this particular puzzle to demonstrate a discontinuous loop type 1. In any event, both those 2 red-colored ones are false no matter how you slice it. All right, next one. All right, here in this puzzle, we could actually make 5 separate discontinuous loops type 1, with the first one being here, with this 7 being proven to be false because it has 2 weak links attached to it in an otherwise perfect loop. Now remember, there's a strong link between this 7 and this 4 right here, but there's not enough room to draw it, so you're just going to have to imagine that. But this 7 would be false. And likewise, we could make another discontinuous loop using this 7 with a weak link going here and another one going over here, okay? So there are 2 of them, but if we envision this as an AIC type 1, like this, then we're going to get 5 candidate eliminations because these 5 7s can see both of those circled endpoints. Okay? So instead of making 5 separate discontinuous loops type 1, you are far better off envisioning this as an AIC type 1, and then you will get those 5 candidate eliminations all at once. Okay, let's go to the next one. All right, here we have the most basic type of discontinuous loop type 1. Here is our cell of discontinuity here in row 4, column 2, and this 9 is going to be proven to be false because it has 2 weak links attached to it in an otherwise perfect loop. But this time, if we try to visualize this as an AIC type 1, here's the other cell that can see both of the endpoints, and there cannot be a 9 in there because that would negate this strong link in column 4. So even though there's a bi-value cell on both ends of what would be an AIC, this 7 is not part of the chain, so there's no strong link in that cell. The strong link is in column 4, so there could not be a 9 in this cell in row 7, column 4, or that would negate that strong link. So here all you get is this 1 candidate elimination in row 4, column 2. All right, let's move on to the next one. All right, this time we've got a discontinuous loop type 1, and our cell of discontinuity is here in row 3, column 6, with this 9 being proven to be false. It has 2 weak links connected to it. And notice that we could make 3 other discontinuous loops using this 9, and this 9 as being the candidate with 2 weak links attached to it. But if we look at this as an AIC type 1, look what happens. We can make a weak link between these 2 9s, and now we've got a continuous loop, Now let me redraw that for you. And now that we have a continuous loop, that means all those weak links have become strong links. So that means we can eliminate all these 9s from block 2. Okay, there's 4 of them. Now you could draw 4 discontinuous loops type 1 to get rid of those, but doing this as a continuous loop, now we can eliminate this 2 because this weak link between these two 2's has become a strong link. Either the yellow 2 or the blue 2 must be true. And likewise in block 9, either the yellow 2 or the blue 2 must be true. So we can eliminate this 2. So by looking at this as a continuous loop, we're going to get 6 candidate eliminations. That's why you have to be on the lookout for all possibilities at all times so you can take full advantage of everything you know. All right, let's go to the next one. All right, here we have another standard discontinuous loop type 1, and our cell of discontinuity is here in row 1, column 7. This circled 7 has 2 weak links connected to it. This is a strong link between that 7 and that 8. So this 7 is going to be false. And that's all you can get from this one because this cell down here cannot contain a 7 or it would negate this strong link in column 5. All right, let's do one more. All right, here in this diagram, our cell of discontinuity is in row 6, column 9, and this 3 is going to be proven to be false because it has 2 weak links connected to it in an otherwise perfect loop. Now, in some of the earlier examples, we saw that we could make multiple discontinuous loops type 1 to get additional eliminations. But in this particular position, this is the only DL type 1 available. However, if we look at this as an AIC type 1 with these 2 3's as our endpoints, there is actually one more elimination we can make that might not be totally obvious at first. We know that at least one of those 2 endpoint 3's must be true, right? So any other candidate 3 that can see both of the endpoints has to be false. And that is the case for this 3 right here in row 7, column 7. It can see both of the endpoints. So even though it is part of the chain, it can be eliminated as false because of a principle called cannibalism, implying that the chain is eating itself. Now this may seem counterintuitive, but it is legal, and if you have watched all my tutorials on AICs, you should already be familiar with this concept. So here in this rare case, the AIC type 1 perspective is actually superior to the DL type 1 perspective because this extra candidate elimination cannot be made by simply drawing an additional DL type 1. In any event, we know that both of those red-colored 3's are false and can be eliminated. Now, whether you choose to envision these things as discontinuous loops type 1 or AICs type 1 is entirely up to you. But when there are multiple candidate eliminations available, the AIC perspective is obviously going to be more efficient because you can save yourself the trouble of drawing the additional 2 weak links, connecting the endpoints of the AIC to each candidate that you're going to eliminate. But I would say just go with whichever way you see first. Get it? Got it? Good. Okay, that's going to do it for today. Thanks for watching. If you enjoyed this video or found it helpful, please click the thumbs up icon and the red subscribe button, and be sure to click the little bell icon if you would like to be notified of new video uploads. In the next video, tutorial number 43, we will take a closer look at discontinuous loops type 2, where we will have 2 strong links connected to the same candidate in the cell of discontinuity. This is actually the best kind of DL to find because it will always result in a digit placement, i.e. a solved cell. So I hope to see you back here for that very interesting and important lesson. In the meantime, be well and be happy.